Guys, welcome back to second part of 11.3. The focus of this will be more on making multiple payments and what's involved with that. So the interest rate that's usually given in simple interest calculations, that assumes that you have like one payment, but most people don't work that way. Most people will pay off a loan or make investments, which is kind of the same math but in reverse. They'll make that over multiple payments, right? They'll decide I'm going to pay off a certain amount per month. When multiple payments are made, what that does is it kind of boosts the effective interest rate a little bit. And so this formula allows you to kind of calculate what the effective annual percentage rate is. Sometimes this is called the APY, the annual percentage yield as well. So anyway, formula depends on how many payments you decide to make and what your interest rate is. So here's a quick example of that. Suppose you buy a refrigerator and it costs $675, but of course you don't have $675. So you agree to pay 20% down, and what that means is you're going to give them 20% of the amount right now, and you're going to take the result, the rest of it, and break that up into 12 equal payments. Now that's a loan, so you're going to get finance charges on each of those. So question is asking us, what is that finance charge, and what is your kind of overall annual interest rate? So first thing, let's figure out what 20% of 675 is, so that we can know what our what is it that we need to take a loan for. So 675%, or $675, if we multiply that by 20%, that's going to be how much we were able to pay right now. Let me switch my calculator on. So 675 times 0.20 is $135. So that means right now we're able to pay $135. If I subtract those, then the balance is 675 minus 135. That's $540. And that's what they're going to charge our interest on. So the interest rate is 9% simple interest. So let's figure out what that is. 540 times 9% is $48.06. 60 cents, excuse me. And so our total amount, we need to pay the $540, but we also need to add to that $48.60. So total is 540 plus $48.60. So $588.60. Now, so the finance charge was the $48.60. The total amount, which they didn't really specify, we needed to find, but that was $588.60. And we need to figure out kind of what is the effective interest rate for this. And so we can use this formula for that. So that is 2 times the number of payments that we have. And so we decided we're going to pay 12 equal payments. And the interest rate is 0.09. and we're going to divide that by 12 plus 1. And so that is on top 2 times 12 times 0.09, so $2.16. And we'll divide that by 13. So 0.16. So 0.166153 and so forth. And so if we move the decimal spot back 2 spaces, we're getting basically all this at approximately 16%. Right, move that over 16.6% interest. If you make more payments, if you split that up into 24 equal payments that are smaller, your effective interest rate increases a little bit. If you make less payments, more amount each time, your effective interest rate is going to go down. And so generally, you want to be able to pay things off as quickly as possible and as big a chunks as possible. It's to your best interest to do that. No pun intended, but I'll take it. But again, not everybody can do that. Sometimes we have to make small payments. If you make many small payments, it's generally costing you more long term. Now, last formula in this section is suppose you've got a loan and you want to pay it off in equal payments and all that, and this is over perhaps many years. For instance, you're probably at some point going to buy a car and take out a loan, or you're going to buy a house and you're going to need to pay that off over the next 30 years or 15 years or something like that. How does those sort of calculations, how are they made? And so here is a formula. I'm not going to sugarcoat it. It's a beast. There's a lot to it. But if we break it up into chunks, it's manageable. All the numbers in here are things that you've seen before, right? A is the amount of the loan. R is the annual interest rate. N is how many payments you make per year, which is almost always 12 because you typically pay things monthly. And T is how many years you're going to make that happen. So let's see how this works. You purchase a television. You're gonna, okay. Sorry, this is just so outside of my realm of thinking that I can't imagine buying a $6,000 television and not having the cash to do that, so you're going to take out a loan. But I suppose people probably really do that. No judgment if that's something you've done, but yeah, I can't afford that and would never do that. Anyway. Moving on, no more editorials. Let's see, if we take out a $5,995 loan on a television with 9.5% interest, and we're going to pay that for 4 years monthly, how much is it going to cost us per month? So let's kind of summarize all these different things. So 5,995, that's our amount. And the interest rate is 9.5%, which is 0.095 as a decimal. N is the number of payments, and as you said, it's monthly, so we're going to do that 12 times per year. And then we're going to take out our loan for 4 years, so T is 4. There's all of our different numbers. Now, I want to find some of these different calculations a second, and I usually break this up into pieces. So if we did R over N, right? Just looking at this part. Well, apparently I can't drag that up here. So if we look at just this part a second, r over n, that's a piece that we can do. So r over n is 0.095 divided by 12. So let's do that a second. So 0.007917 and so forth. So r over n is that, and that was 0.00791. So technically I think that decimal goes on and on and on, but at some point we need to cut it off and round. Generally, you'll want to keep as many decimal places as possible for these answers to be as accurate as possible, and only at the very end probably round to the nearest penny. Now, this r over n calculation is actually useful twice, right? It is the numerator, but it's also part of this chunk down here. So let me add 1 to that, and that's the part that's in the parentheses. So I've calculated that, and I've calculated this much a moment. Now the nt, so n times t, that's 12 times 4. I should be able to do that, but I'm really tired. So 12 times 4 is 48. So nt is 48. So there's a couple more pieces. So now we've done this much. And now I'm going to do the parentheses, the 1 plus r over n raised to the negative 48, and see what that is a moment. So 1.007916667. I want to raise that to the negative 48. So for that one, we got to turn our calculator sideways. So we have the exponent button. So 1.007916667 raised to the negative 48. So in order to do that on one of these calculators, do you see how right here it says plus or minus? So I'm going to have to take 48 negative and hit enter. And I get this 0.684 sort of number. So 0.68488. So that chunk is, let me maybe show that much in purple. So that was this part of the formula. So now I can do 1 minus that, and that's the bottom. So 1 minus 0.68488. So 1 minus 0.68488 is 0.31512. So that's the bottom, and I think we're just about ready to be done. So now what I'm going to do is a times the top divided by the bottom. So A is 5,995. So 5,995. I'm going to multiply that by the top. The top was the r over n that we found a long time ago. 0.007916667. And I'm going to divide that by the bottom, which was this most recent number, 0.31512. So divide by, oh bother, I think I already hit divide. Let's try that again. 5995 times the top, which is 0.007916667, and we're going to divide that by 0.31512. So $150.61 is what we would need to pay each time. Phew. So not the most enjoyable formula, but again, if you could break it up into chunks, it's doable. I also show you one last example of this where we use the calculator, like a TI-83 or TI-84 calculator, and store some variables. That can be a little bit more convenient, perhaps. So, similar sort of question. We've got a loan for college. No, excuse me, a loan for a new car. $18,395. There's some sales tax. You also have to pay something for a licensing fee, and then you're going to pay some down payment, but you're going to have to take a loan on everything else. So let's break this all down into its pieces. $18,395. There's also a 6.5% sales tax. So let's figure out what sales tax is. 18,395 times 0.6065. Or you can do 6.5 divided by 100. That works too. Maybe that's more convenient. So 18,395 times 6.5 divided by 100. So sales tax is $1,195.67, 68 cents. And then there's a licensing fee. So let's figure out what the licensing fee is. Kind of calculated the same way. Total amount. This time it's 1.2%. So let's find that. 18,395 times 1.2 divided by 100. So to get the license, it costs you $220.74. So the total amount that's due is $18,395 plus each of those different fees. So plus $11.95 and $220.74. So that is $19,811.42. Wow. Okay. Now, you did say that you would pay a $2,500 down payment. So if we paid $2,500, we can take away that $2,500, and we still owe $17,311.42. So we paid $2,500, and therefore we owe $17,311.42. And that is what we decide to take a loan for. So that's our A. That's the amount of the loan. The interest rate is 7.5%, which is 0.075. The number of payments per year is monthly, so that would be 12. and the number of years that we're going to pay off our car. Did they specify that somewhere? 4 years. So time is 4. So it took us quite a bit just to even get this problem started. But now let's calculate what our payment is based on this formula. And so I'm going to switch to my calculator app. And the amount, so that's 17311.42. See if I can make that a little bigger and easier for you to see. And so I'm going to store that. Remember the stow key right here. We'll store that as A. And then we'll do 0.075 we'll store as R. And 12 we'll store as N. And 4 as T. Now, typing this entire formula into our calculator is actually pretty challenging. You need to put the top in formula or in parentheses and the bottom in parentheses and multiply that whole thing by A, and it's kind of a beast. So I still probably will chunk it, but I might do R over N. And that's the top. So I might store that as the letter, well, I can't store it as T because I've already got T in there. So, but you could use some letter you haven't used, like maybe the, what letter haven't I used? I've used like everything. Maybe I'll store that as X. So the top is X. Now in the bottom, I've got 1 minus, in parentheses, 1 plus R over N. And that needs to get raised to the negative N times T. And so I'm going to once over this again, kind of make sure that that looks right. 1 minus 1 plus R over N raised to the negative NT. I think that's good. So I'll hit enter, and I'll store that as the bottom. I used X for the top, so maybe I'll store that as Y. And now I figured out the top, I figured out the bottom, and so kind of the overall calculation is A times the top divided by the bottom. So the loan amount times the top, which I stored as X, divided by the bottom. And so this calculation works out to $418.57. So the monthly payment is $418.57. The total amount paid is the monthly payment times 48, because we made 48 payments, right? So if we multiply this by 48, we get $20,091. So the total amount paid is $20,091.41. You'll notice that's more than what the total loan was. And that's always going to be the case. If you take out a loan and pay interest on it, you're going to end up paying more than the actual loan was. So it doesn't surprise me that that's more. Anyhow, that's a monthly payment sort of calculation. And Yeah, good luck. Let me know if you have some issues, and I will see you next week.